Okay, hello. I hope that worksheet went well. One of the things I promised to do was to show that x squared is bigger than this number over here. I'm going to do that by, oh shoot, I had some failed attempts, to be honest. I was stupid. So yeah, we're going to graph these two things. So this red guy is x squared. This blue guy is this 9999999x. It looks like it's a straight line, but it's just so incredibly steep. This is not a straight line, or it's not like no, it's not going straight up. It's a straight line, but it's just incredibly steep. Um, and I'm gonna say that even though this line is so incredibly steep, the red line is eventually gonna get above it. Um, it's gonna take a very long time, but it'll eventually get there. We're gonna go there. We're gonna go so incredibly far out. These numbers are gigantic, by the way. Oh, I think okay. I have to go past like maybe to the 30. Yeah, this is probably good. Okay. Okay, I'm gonna zoom in here. Let's just pick this spot. This should be good enough. I'm not. I'm somewhat picking a random spot, but I made sure it was bigger than something. Okay, I'm still zooming in. I feel like I'll probably have to go even farther out. Oh yes, yes. There we go. Okay, so I wait. Here, wait. Let's look at. Show me it. Okay, yes. So we are here. What point is this? Give me a point. Oh wow. Yeah, we are very far away. This is where we are. We're both like so far up on the first quadrant or the top right. But look at this. So this was the blue line from earlier. Well, this is just a line. And you can see we went all the way out and the red line finally beat it. Like this is it's like I know it's a little bit confusing because it's to the left, but it's now like basically on top of the blue line. It's like if you think about it, uh just because like it gets like for example this to this like line right here. The red line reaches it first. Like when you're going to the X, it reaches it first before the blue line does, which shows that the red line is currently above the blue line. I know it's very confusing. They both look like they're straight up. I promise you, they're both just incredibly steep, and now this red line's on top. Um, which is very ridiculous because if you remember where we started, let's go back to where we started. Like it looked like this. Like the red line was so incredibly steep, but the blue line is doesn't look that crazy, but it gets there. It gets there. So no matter what number you put, if you put as big of a number as you want, eventually x squared is gonna beat it, and I'll bet my life on that. Okay, why does that happen? Let's. I also want to explain why this happens, and to do that, I'm gonna do like a more chill example. So this one, so you can really use any number here. I went with 100 though. So we're gonna compare these two guys. Y equals 100x and x squared. We actually probably did this already. We actually did do this already. So for this guy, so it just keeps on going up by 100 every time. This guy does not go up by 100 every time. It starts off slow, much slower, but then it speeds up a lot. But either way, so it's looking something like this. X squared starts off so much smaller. But let's go let's first okay, one point that you have to think of what does it mean to square something? That means to multiply it by itself. So like so x squared is really x times x. So like you could have thought of this as 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5. Like that's how you got these numbers. 6 times 6. Okay. And here this is really 100 times x. So this guy is really 100 times x. This is x times x. So if we like fast forward a bunch to get to 99, this guy is going to be 100 times 99. Next one's 100 times 100. This makes sense because we've been counting by hundreds. 100 times 101, 100 times 102, 100 times 103. Oh, more. We're doing more. 100 times 105. So yeah, so these are very big numbers because we've been counting by hundreds. These are huge numbers. What's happening over here? Over here, remember this is like x times x. So here it's 99 times 99, which is smaller than this. That's smaller than this. So 100 times 99 is bigger than 99 times 99. So like here, like I'll bold all the spots where this guy's winning. Oh shoot, what is happening? Here though, what's going to happen next? So here, this is 100 times 100. Because it's x times x, x is 100, so it's 100 times 100. Now they're tied here. They're now tied. But next up, it's going to be 101 times 101, which is definitely bigger than 100 times 101 by a very little amount, but it's bigger. Next one's 102 times 102. And next one's going to be 103 times 103. This one's 104 times 104. This one's 105 times 105. So as you can see, the moment it passes this guy, the numbers here are just getting, they're just going to keep being bigger than what's over here. Because like the difference here is that this is x, this is 100. Once x becomes bigger than 100, this guy is just going to be way bigger. And once again, this is like accelerating so much. Because like a parabola is like a u, this, no, don't worry about it, don't worry. What you need to know, should hopefully give some intuition about why, like if I make this, like it doesn't change if I made it a binary number. We just have to wait longer. Because eventually the x is going to match it, and then it's going to start getting bigger. So yeah, hopefully that explains why that makes sense, and hopefully explains like why x squared eventually beats this guy, though this guy is ridiculous. Takes a ridiculous amount of time, but it happens. And that's why x squared is powerful. Goodbye.